Welcome back. This is part 2. We're going to be creating the PCBs for the microphone preamp for dynamic microphones, and we're going to put photoresists on the PCBs and develop them and so on. Just to do a quick recap, previously we developed the PCB using KiCad, and we have actually gone to the plot function here, and we have do these settings. Now we say turn off plot edge cuts on all layers. We've turned that off. We want a mirrored plot, a negative plot, and check zones before plotting. And then you will click plot. I've already done it, so I won't do that right now. And note that we set the format to PDF here. And when we do that, we should have a file, a PDF file that we can print on transparency film. As you can see from the camera there, this is the transparency film that I use. It was the cheapest ones I could find on Amazon. And actually I have the little transparency here that will be used to make the PCB. Note that I've made two PCBs. One is a little bit different from the other, and I encountered a few problems, and this is actually the final one. I interjected this video with this final version. The one that you'll see being developed will be slightly different, but the process will be the same. So that is what we're going to be doing next, and we're going to take the PCBs, put the photoresist on there. I generally let them dry for 24 hours. If you use a hair dryer on it or something like that to heat them up, then you can probably do it after like 8 hours or something like that, but you got to make sure that the photoresist is not sticky anymore. Anyway, no further ado, so let's go and do the PCBs, put the photoresists on, and take it from there. Okay, so I've cut off two little pieces of PCB of the right size, and as you can see, this is what's going to be etched on there. They are 26 millimeters by 46 millimeters, or maybe. And for the inch bound, that is just a tad over an inch. Let me pull this down so maybe a little bit over an inch, and about an inch and 3/4 or thereabouts. Full. So this is the photoresist that I have. Looks a bit messy because when they sent it up from China, it leaked in the bag. If you go to eBay and AliExpress and what have you, you'll probably find quite a few of those. It's cheap stuff to buy, and it's just like gooey stuff. And what I do is I use one of these little rollers on it. I've seen other people trying to use spatulas and little scrapers and things, and this is the way to go. This is like a little roller. I have, let me see if I can get the bigger. Get the bigger camera going for a sec. See, this is the little roller that I actually, little one that I use. I also have a bigger one for bigger PCBs. You can buy those online as well. I bought them as a, use them for inking things and stuff. Okay, so I need to get a little spatula. Okay, you don't need much of this stuff. Maybe just a tad more. The roller is dry. Goes onto the little roller. Okay, that's one done. Sorry about that. Just okay. That's it. So I'm gonna let these dry, and then we'll go on to the next step. Okay, this is the plan. I have this little drive bay that I taken out of an old PC that I actually use for this. Of course, you can use anything. I have some little pieces of glass which I stole out of a little picture frame. I'll put one piece in the bottom, and then I have another piece which I will put on the top of the negative when we get to it. I have a UV light here that I bought, I think on AliExpress or something. Let me move this over. It's actually a 10 watt, which is quite powerful. It's meant to be like a little floodlight. And with this, I only have to radiate the thing for like 60 seconds or even less sometimes. So it's nice and quick, and I can stick it just on top like that. It's got the right distance. Put a bit of Velcro on there in order to so it doesn't slip off. I've got a little tray here of water, and if you look at some other videos from other people, they tend to use washing soda, but washing soda is only a little bit caustic. And here we have pure lye drain opener, which is 99% pure, and that is very caustic. So just a few little grains of this will develop the photoresist even better than washing soda. So I don't use washing soda. I use that instead. Now, when I'm doing this UV stuff, I use these glasses here because this is quite a powerful little light here, and I have noticed that if you use it and you look at the light even a little bit, your eyes get sore, and when you get old, you don't want to get cataracts, and other problems. So it's best to wear some UV glasses. They only cost a few dollars. And I'll show you some other options too that I have. Okay, so if you do not have a powerful light, there is also these kind of things. I bought some resin, and this actually came with it for free. Mr. Resin, it says it's got some UV LEDs, and it can sit on, you could put your thing underneath it like this, and that will work as well. But it is nowhere near as powerful as this one, so you'll probably have to irradiate it for a couple of minutes instead of only 60 seconds or something like that. I don't know. I haven't actually. I've always used this one, so that's another option. Or some people have had some success, I think, putting it in the sunlight. I have no experience with that, so I don't know. Okay, so I put that in there. And I'll put this piece of glass right on the top to weigh it down. All right, and I'll put the light on top. I'll put on my glasses. And let's have a look now. I forgot a little timer. Okay. I'm just looking at the clock there. I'll wait till it says. Okay, turn on the light. Now, let me shed a little bit more light on this. Okay, so I've got a tiny little pinch of sodium hydroxide here. Here it goes. Dissolve it. And this is probably not that critical. Put a little tiny pinch in there, and if it's not strong enough, then add a little bit more. But don't add too much because it might remove the whole thing then. Okay, in it goes. And we will use one of these little hobby brushes that you can buy at Harbor Freight. And I am going to, while this is soaking a little bit, I'm going to put on a rubber glove because sodium hydroxide doesn't do nice, even if it's not very strong, it doesn't do nice things to your skin. Okay, you can already see that it is developing very nicely. Here we go, look at this. You can be pretty gentle with this little brush. Now let me have a look now. Very nice, I think. Look at that. Very good. All right, so if we need to touch anything up and it doesn't look like there's much there, I use nail polish. I'm going to just cover up this edge here. I don't particularly need to, this is a ground plane. I don't particularly need to etch that off. And let's have a look. A little bit over here. I think that's all we need to do. Yep. Okay, so I use the old-fashioned ferric chloride for etching the PCB. I buy it as powder, and so it keeps a long time as powder. I don't have to dilute it. I dilute it and I keep it in a little bottle, and each time I use it until it gets spent, I will add just a tiny little bit of fresh ferric chloride to it to make sure it keeps its strength. We'll try that first. I can always add more to it. This kind of PCB is kind of translucent, so it makes it a bit easier because we can put it in the solution here, and when we think we are done, we can hold it up to the light and see through it and see that all the copper is being removed. This is okay. Just let it sit there for a bit. It's going to take a few minutes, so I might stop the camera and resume when we're getting close. Okay, been a few minutes and it's done. And I hold it against the light. I can see right through, the PCB, and I can tell, whether there's any areas that may or may not have been done. So everything looks good. So I'm going to wash it off now, and we'll go to the next step. Okay, so now we're going to have to drill a few little holes. I've got a little drill mounted in a little portable, whatchamacallit, drill. And I think I need to move the light. I can't see it very well. Yeah, that's better. Okay. Okay, so I've got the little holes drilled, including the mounting holes. I did those with a bigger drill, 2 millimeters, and this is the little drill that I use. It's a USB powered little unit, and it wasn't expensive. I got it from AliExpress, I believe. So now we got to get the photoresist off. In order to do that, I tend to use paint stripper. It's the easiest thing to use. So and I'm just gonna paint that on there, and I'll just leave it for, I don't know, 10-15 minutes, and it should all be coming off. So let's go and do that. Open this up. Let me shake it up a bit or something. Now the original paint stripper that you used to be able to buy had methylene chloride in it, and for some reason this was a pretty noxious sort of chemical, but it worked wonderfully. And they now have a methylene chloride free formula, which is what this is. You can't really get the old stuff anymore, and quite frankly this stuff is way slower. It doesn't work as well. That's why I have to leave it. If this was the old-fashioned stuff with the methylene chloride in there, it'd be coming off straight away. But that's his life. Okay, I'm just going to leave that now, and come back when it's ready to come off. All right, this stripper has done its job, I think. There we go. All gone. So I'm just going to rinse this off. I'll be back. So that is it. This is our little PCB that we made. And next we're going to solder the components on, and then we will test our little preamp. But we'll do that in part 3. So this here I've shown you a complete manufacture of the PC board from KiCad to the finish. So next part we're going to actually use it. And the first part, of course, you can watch part 1 in order to see how we put the circuit in KiCad and how we develop the PCB and all that kind of stuff. Okay, so the next thing that was going to happen is to go and show how to complete the PCB and soldering up the components and stuff. But when I did that, I ran into some problems, and I thought I would show that here, a few of those things, because we have to make changes to the PCB, and I will show in the completion video, I will show how to add the components to the a different PCB than what you're looking at over here, where I've made some changes to. But let's have a look why we had to do that. So the first thing you'll notice is that I'm experimenting actually. This is the first, as I said a few times, this is the first PCB I made for surface mount components. And it's a homemade PCB, so we don't have a solder mask. If there was a solder mask on this PCB, I wouldn't have had to make changes to it, but because we have a copper fill zone for the ground plane, it is easy for the solder to get underneath the little components, and actually, like over this one over here was shorting out, and as you'll see me soldering this, some of the solder is actually flowing across. You will see that happen. Also, I have a whole bunch of T12 tips that I bought, like how many have I got? 1, 2, 3, about 15 of them or something like that. They're all slightly different, and I wanted to use this bent tip over here, but that ended up not being an ideal tip for soldering here. So I won't be using that one for this purpose anymore, and you'll see me using a different tip which worked better. It's a little bit fatter and not quite as long, so that the heat was flowing out of it better. And let's start the video here so you can see what's happening. It is difficult to get the solder to melt properly on the ground plane. Also, this solder, I bought it, it's a mechanic brand or something, and I bought it from AliExpress, and it's supposed to be 60-40 standard leaded solder, but it is not as good as some of my old leaded solder, I must admit. And I think I better buy some solder from some reputable sellers in the United States instead of from China. So as you will see, what's starting to happen here is that the let me pause it for a sec. The solder over here is actually getting very close to that pad over here, and you'll see it actually later on flowing into that pad. And that is why, for a start, we made the gap here a little bit larger, and also I took out the zone filling in these areas where the pads are. So the one thing that you'll see me doing here is that see, there it goes. Some of the solder has actually flowed onto the over there, bridged onto the other pad. And that's also because the solder wasn't melting very well, and there is flux there. It should have been better, but I had to use a better tip, or I'd have to use more heat, I suppose. So what you see me doing here is I've only put solder on one pad, and then put the component down on it and solder the one side down, just tack it down basically. Then that allows the component then to seat properly onto the PCB, because there's not a blob of solder on the other end. So then you solder the other end, and then you go back and touch up the first one if in this case, you know, the solder wasn't melting properly. But at least, as you can see, the solder, when it melted and with the flux on it, it did recover the trace over there. But you see how easy it was for some solder to actually bridge it. Okay, so next I tried to see what you could do with some hot tweezers. Now the hot tweezers I've got, I have not found any that are actually ideal. There are some good tweezers out there, but they tend to be $300-400 just for the tweezers, because yeah, they will come from companies that sell, like Weller and some of the others, Hecco and so on. They sell to professional companies and they charge through the nose. And the actual, I think the cheapest I've seen is about $900, I think, for a soldering station with some tweezers with it. Now they are probably one of the only tweezers that work properly. It is true. The Chinese have not copied any of those and made a cheaper versions of it. And these particular tweezers here let's start it off again. They do work, and in order to use the tweezers I would have to put solder on both pads, which is what I'm doing over here. And as you see, I'm using a different tip here, which is actually working a lot better than that little skinny bent one. It's like a knife blade tip. Okay, so here's the tweezers. We're going to pick up the little components. Now these little resistors are very flat. They are hard to pick up with any kind of tweezers like that. But it dropped out. I had to turn it around. Okay. Nice if I can keep it under the microscope. So there we go. Started to center it. So you can use tweezers, as you can see, and quite frankly, if this was a manufactured PCB from the manufacturers and there's a solder mask on there, it would be actually probably one of the easier ways of soldering on the components, even with the tweezers that are less than optimal like that. Now later I also soldered on that little component over here. There's a capacitor with the tweezers, and somehow the solder got underneath and it was shorting out, so I actually had to remove it again. And in fact I had to remove some of those components and try to redo them. But what I actually did was I tried a few more, and even when I soldered on the little IC, I was getting, pin 1 was getting shorted to pin 2 underneath somehow, and it was a mess. So I put on some solder resist. You'll see me doing that. Hold on, I'll fast forward to that. Okay, so here I put on some green solder mask, UV curable solder mask in different places where I was worried. See, like that little island here that's close to the pins. This island over here that is close to those pins, and underneath here and over there, put on, and that fixed it for that PCB. So it did end up being a successful build on that one, but you will see on the second PCB I will have removed that excess copper from those areas, and that one was much easier, and I didn't have to put that green UV solder mask on there. I filled in the zone here, and it put a ground plane between where the little components go here, and you see it over here in the between the pins of the IC and the sort of a blob of it here, like an island, and over here as well. So this was problematic. Also the distance between the ground plane and the traces was also a little bit small in some areas. So when I soldered on those surface mount components, there was a tendency for the solder to, as you can see, like for instance, these over here, there's not much of a gap there. Some of the solder to get caught underneath the component and shorting out to the ground plane. And I had to go in and make changes to the PCB, and that is what you will see that I have done with the second iteration of this, which is actually at the top. This is the old PCB and this is the new one. You notice that there is now clearance between the surface mount components, and there's no ground plane between the different pins, like here and so on, and over here, and those ones over there. And that was what was required in order for the surface mount components to be soldered on correctly. I had a lot of problems with the original one. There'll be some glimpses of that I will, as I will have shown. Line, and you can actually draw shapes, as you can see here. And when you accept that, I'm not going to because I don't need that there. Hit escape. When you accept that, it will then create an area in the zone where the fill will not fill it. And as you can see, I have already got, oh, gotta get out of it, sorry. Okay, so now I clicked on the zone cutouts, and as you can see with all the areas there with the little white boxes around them, like that section there, and there's the one here at the bottom, there's one at the top, and there is one here around the components and part of the LM358 IC, because I did want the ground plane to reach the pin at pin number 4 there. So when you do that, then that is how come when the zone was filled that these areas over here don't have the zone fill on them. And that is what required in order to do a successful PCB. Also, I increased the size of these gaps between the zones and the traces, and I think you just go to properties, like that, and as you can see, I set it to 0.6 and minimum width 0.5. I could have made it 0.7, but if you make it too large, like this little trace up the top here might be missing then, and then it is not, this ground pin here may not be reached, and so on. So I found this to be the ultimate for this particular PCB, and there was enough clearance there now to properly solder things without any problems whatsoever. So I thought I would add that to it, because you will see me doing the second PCB and soldering components on there. So this is what happened. It was experimental, and now I've got it nailed down. I know what the parameters should be for the next project. Okay. Okay, well, that came out pretty good. This is the negative, and that is the PCB after I put it in a little bit of water with some lighter to develop it and to remove the unexposed resin. So now what I'm going to etch it. And again, I'll do that off camera. It came out good so far. So I've shown you before how I etch it. I'm just using this ferric chloride, and I'll be back when that's done. Okay, this is the PCB after etching, holes drilled, ready to go, and this is what we'll be using in part 3 to solder together and to test it to complete the build.